In this video, we will be discussing the history of computer, particularly the tabulating machine and the Harvard Mark I. These machines were part of the earliest forms of computer programming.
Tabulating machine, invented by Herman Hollerith in 1890. Good day everyone! So ngayon, pag-uusapan natin kung ano ba ang tabulating machine. So, ang tabulating machine ay invented by Herman Hollerith. Si Herman Hollerith ay isang American engineer. Herman Hollerith, a German-American statistician and inventor. His successful prototype was demonstrated in 1889. The system was first used for the 1890 US Census. So guys, nag-start ang tabulating machine when Herman Hollerith was watching a train conductor punch tickets. And since he's an engineer, doon siya nagkaroon ng idea na bumuo ng isang tabulating machine. And after that, inassist naman ni Hollerith ang US Census Bureau na nagtatrack ng population data ng mga American citizens. And ito pa guys, since hindi pa nabubuo o hindi pa nag-exist ang tabulating machine, inabot ng 8 years ang US Census para ma-finish ang 1880 Census. And dahil doon, natakot sila na baka abutin ng 10 years or more than 10 years ang pagbuo sa 1890 Census. Ang tagal, diba? And because of that, nakabuo sila ng Computing Tabulating Recording Company or ngayon ay mas kilala na as International Business Machine Corporation or IBM. Purpose and functions. Data processing. A tabulating machine's primary function was to automate the counting and analysis of big datasets. Counting and sorting. Based on the patterns of the holes in the cards, the machines could quickly do statistical analysis and count and sort the data. The tabulating machine uses electricity para mag-read, mag-count, and mag-sort ng data. O diba guys, ang galing? Kung dati mano-mano pa tayo sa pagbibilang ng mga data, ngayon, mabilisan na lang. Purpose and functions. Punch cards. Cards had holes in them that stored information that the machine would read to do its job. And now guys, pag-uusapan naman natin ang punch cards or na ginagamit sa tabulating machine. So, ang tabulating machine ay gumagamit ng mga punch cards na may mga holes. Ang mga holes na ito ay nag-represent ng mga data na nag-gather ng mga census takers. And now guys, let's proceed to Howard H. Aiken.
1. By Howard H. Aiken in 1943.
Harvard Mark I was invented by Howard Hathaway Aiken during his time as a Harvard professor of applied mathematics. The intention behind the creation of this machine was to relieve the labor of solving numerical equations using a pencil and paper.
The Harvard Mark I, officially the IBM Automatic Sequence Controlled Calculator or ASCC, was a large-scale electromechanical computer built by IBM in 1944 for complex calculations during World War II.
The project initiated in 1939, months before the World War II broke out, when the then head of IBM, Thomas Watson, agreed to fund Aiken's idea. This machine was created in collaboration with IBM engineers and was originally called the Automatic Sequence Controlled Calculator or the ASCC. but then became the Harvard Mark I when the machine was given to Harvard University.
Grace Hopper wrote the first computer manual for the Harvard Mark I. She also coined the term bug when a literal moth caused a malfunction in the machine.
The original machine was 51 feet long and 8 feet high. It could do 3 additions per second, multiplication in 6 seconds, and division in 15 seconds. Even though it was a slow work, compared to using pen and paper, it was still a great advancement.
Key features and functionality. Purpose: designed to solve advanced mathematical physics problems and complex calculations. It was used extensively by the U.S. Navy and in the Manhattan Project. Electromechanical design: unlike fully electronic computers, the Mark I used mechanical parts, relays, and electric motors to perform calculations. Programming: to get programs into the machine, people used paper tape with holes punched in it to hold data and orders. Its primary purpose was to solve the most complex mathematical calculations of the time. It was electromechanical. Crucially, it wasn't a fully electronic computer, like a laptop. It used thousands of mechanical relays and switches, powered by electric motors, to do its math. This made it huge and complex. Unlike today's generation, you couldn't type on a keyboard. Programs and data were input by punching holes into a long strip of paper tape, which the machine would then read to follow instructions. Historical significance. World War II contributions. During the war, the device was essential for computations related to radar design, ballistics, and the creation of atomic bombs. Successors. In order to further advance computer science, ICANN continued to create its successors, the Mark II, Mark III, and the fully electronic Mark IV. Why was it so important? First, winning World War II. This machine was critically military assets, providing the necessary speed for calculating ballistics, designing radar system, solving the immense mathematical equations needed for the Manhattan Project. The Mark series, the success of this first machine proved the concept, led directly to the rapid development of its successors, the Mark II and the Mark III, which improved the design. The leap to electronic, the research and development culminated in the Mark IV, which was the ultimate step to a fully electronic computer. This is the moment the technology moved away from noisy, slow mechanical parts and into the realm of modern digital speed. This short video explains the mechanics and the major historical impact of this early data processor.
This is the Hollerith tabulating machine. It is one of the first electrical tabulating machines invented by Herman Hollerith in 1884. Now, it is used later in 1890 for the American census. You would have a card for that census to collect different data. They're looking for race, gender, age, illiteracy, as well if you are born in the United States or an immigrant. You would take that information, that punch card, it would be put down here. You're going to create an electrical circuit. When these little springs, they would come down. Mercury is also going to be used to help conduct that electricity. That information then is calculated along these dials. The Hollerith tabulating systems, they later became IBM. Prior to this invention, when women were joining the industrial workforce, they were mainly working for the census. They were collecting that data, calculating that data, and writing it down. Therefore, they were trained to use this invention.
Now, we look at the Harvard University Giant Automatic Calculator. Watch as we see one of the earliest predecessors of the modern computer in action.
A triumph of mathematical and mechanical skill is this great new automatic calculator at Harvard University. Intricate problems in mathematics, put through the machine in coded form on tape, are accurately solved in a minute fraction of the time required for human calculation. Designed to expedite all forms of mathematical and scientific research, the giant mechanical brain will work for the United States Navy until war's end.
I'm Harry Lewis, and I'm standing in the Science and Engineering Complex of the Harvard Paulson School of Engineering and Applied Sciences in Allston, Massachusetts. And I'm standing in front of the Aiken IBM Automatic Sequence Controlled Calculator, better known as the Harvard Mark I. The Harvard Mark I was an early electromechanical computer built in the 1940s, the early 1940s. And when I say it's electromechanical, what that means is that it's full of gears and motors and cams and levers. This was like a huge mechanical calculator, except that the sequence of operations that it was to perform, what we would today call the program, was punched into paper tape and could be executed automatically. Add these two numbers, divide by this number, and so on. So this machine was used for printing tables of the values of numbers. It was also used for ballistics calculation. It was used for some of the early calculations in the Manhattan Project, in the design of the atomic bomb. So what does the Mark I physically consist of? These are their registers. Each one contains one decimal digit, and those wheels would all turn independently and accumulate values as arithmetic operations were being carried out. The dials with the knobs on them are where you could put in a constant. So you can see each one is a little knob and it has 10 positions. If your program required a value of pi, let's say, you could dial the values of the constants in there. The program was on paper tape, and the punched paper tape would just be scotch taped together to make a continuous loop. And then finally, these electric typewriters were used to print the output. So this is the Harvard Mark I computer. It was a marvel of its time. It made all kinds of calculations possible that would have been extremely time-consuming to do. But you have more computing power than this machine by a factor of thousands in the wristwatch on your wrist.